Okay. All right. Welcome, everyone. So everybody here is having a good time so far? Or, yeah? Good, good. Or almost getting there? Getting warmed up after a great lunch? So yeah, an interesting story. So today at lunch, I had the steak and the chicken. So one time at the buffet line, the server asked me which one I wanted. And when I said both, the server looked at me kind of strangely and was like, why would you want both, right? You already have all this meat. But that's what Wiwynn is here today to present, because we have a whole spectrum of products, ranging from OCP, Project Olympus, and Cluster Manager, as well as 12-volt and 48-volt variations, all on display on our booth. And I'll give you a good overview in my presentation, so stay tuned and hope you enjoy and gain some knowledge from this. So last year at OCP, we really witnessed the growth of OCP ecosystem, ranging from the partnerships, from the technology at the fundamental level, and all these business connections intercrossing. And just in 1 year, really, the industry has really seen the rise in the age of AI in just this past year, just application-wise, the whole industry. And that's really what, as we've seen even today's expo and all around you, even in the news, the media, that AI is really driving the industry forward. And this driving force, as you can see here on this chart, okay? Oops, excuse me. Let me, okay, so starting from the applications of AI, various like deep learning, machine learning. And what is driving that underneath that is the infrastructures of these applications. So and these infrastructures serve as your building blocks for your AI applications. And also an interesting category is the demands of the evolution of the data center, which haven't really changed over the years. Because as you've seen, the fundamental demands are such as performance, power, cooling, and data storage in the data center. These are kind of, time and time again, we'll see these demands are driving the evolution of technology in the data center forward. So where does Wiwynn fit into all of this? We really provide the infrastructures of the data center moving forward. Oops, excuse me. Okay. And how are these infrastructures at Wiwynn organized? So the first one is the OCP rack, of course. This is a big theme, as always, in open compute. As well as in our booth, we have the Project Olympus. We have a full-size rack there. You can go check it out with new products within the rack. And we also bring to you, very interestingly, the compute accelerator, which has the AI application, serves the AI applications, as we all know. Okay. Whoop. So based on these three building blocks, what are the specific infrastructures we have on display and that you can actually touch and then see for yourself? So we have the Tioga Pass and the Yosemite version 2, as well as Bryce Canyon. That rounds out our OCP 12-volt machines on display. And for our Project Olympus, we have the Compute 1U server, and as well as a new all-flash storage utilizing ruler stick concepts, which you can actually take out and insert back in. You can check it out, the ruler SSD form factor, how that works in our booth. And rounding out the last two for our compute accelerators, we have what we call a Dr. Node G1 and a Dr. Node G2 Generation 2. And these serve as powerful compute accelerators that can be hooked up to multiple hosts to run your various AI applications. So this is a basic view of how our booth looks like. And funny enough, that's how it's organized, the three categories I mentioned. So the first one is we have 48 volts that'll be on your far left. So that's a live demo there. You can see how the 48-volt half rack is being powered and shown in a live demo that it's around 48 volts for the power. And as well, we have OCP products in the front line, namely the Yosemite version 2, you see the Tioga Pass, and also the Bryce Canyon in the middle. And we have the two compute accelerators I mentioned, the Dr. Node G1 and G2 lying in the back. Okay, and then as well as it has a live demo, you can see the throughput performance of the G2. And we have Project Olympus, the full-size rack there. And from the side, if you from the right side, you can see our new F2010, which is the ruler SSD 1U unit. And finally, we also present software solution, which has cluster manager with Intel rack scale design, utilizing the latest rack scale design of 2.3, and the main feature of NVMe over Fabric, which you can check out. We have a live demo for you as well. So starting off with the 48-volt rack, this is the basic GUI. If you go to our booth, you see the power is consistently around, generally around 48 volt. And it's getting that from the sensor management data. So you can check out our booth over there, and you will be able to see further details. And then going towards a little right on our booth, you can see the compute accelerators in the back. And this is a 4U 2-drawer. It has 8 GPUs in each drawer. Now, a good cool functionality is one of these drawers can fit 2 Tioga passes. So it essentially turns from a JBOD into a GPU server. Okay? And as well as it can just serve as a JBOD connecting to 1, 2, or 4 hosts. And a total of 16 GPUs if you just want to put purely GPUs in this box. And it utilizes the latest PCIe 4.0 technology. So that's the cutting edge difference between this and previous PCIe 3.0 GPU technologies we're seeing around the market. So as well on our booth, we have the live demo. And as you can see, this is OS view. So just testing the throughput of the PCIe 4.0 box. So you can see how the throughput is ramped up as you run these throughput tests. So yeah, more details right over there. So please come to our booth. Check it out. And finally, moving on to the Project Olympus rack, we have the ST5100, which is the ruler form factor I discussed. And this is, as you know or are aware of, the Microsoft rack has its own rack management. And this 1U form factor fits into the rack smoothly via blind mate connection with its standalone CPU. And it's also front I/O serviceable, which is congruent with the Project Olympus design. And then, as you can see, there's 16 ruler SSDs in the front. And each one can actually just hold the Intel form factor ruler SSD, or it can fit 4 M.2 SSDs. So there's 2 variation of SKUs you can experiment with. And this is really for storage and data intensive applications utilizing NVMe if you need that kind of speed for your storage, JBOD. So for ours, and the next, moving on forward, we have the Intel rack scale design. And we have several infrastructures that are all compatible. And RSD supports this wide spectrum of infrastructures. So starting with the 12 volt, we have the Tioga Pass, we have the Bryce Canyon, and Lightning. And these are typical building blocks in your data center. And then we also, RSD supports 12 volt, 48 volts, and 19 inch. So Wiwynn offers full coverage for RSD so far. And yeah, it's coming with also the compute accelerator and the 19-inch multi-purpose server. So we have the whole thing around 12 volt, 48 volt, 19-inch. So here, I'll give you a short video of the latest RSD 2.3, and which is the highlight of the NVMe over Fabric technology.
Introduction of RSD 2.3, where we compose a node with NVMe over Fabric drives. So welcome to the GUI screen of Wiwynn's RSD 2.3, and you can see an overview of all the rack, including the nodes inside. And here we see an overview of the processor, memory, network, and drives information of a particular node. And in this feature, we want to highlight the NVMe over Fabric pool, as you can see here. And in this next step, we'll compose a node in which we can create an NVMe pool out of the available NVMe pool capacity we have available. So moving on, let's specify which rack that we want to extract or compose a node from first. So let's just select this item, for example, click on Next. And for our capacity here, we can specify, let's say 100 gigabytes, and do Next, and finish. So just with a few clicks now, we have our NVMe pool. Okay, so here we want to check the composed node to see if the specifications are what we specified earlier. So we can see here our composed node, the processor, memory, the network, as well as the NVMe details. And let's boot up the system first, because NVMe over Fabric, we should be able to see after the system has booted our desired NVMe. So logging in, we can see that the NVMe drive has been attached, but it's actually 100 gigabytes of capacity. And we can delete the node with one click, very easy. And so we see back in our NVMe pool, all the storage NVMe has been restored.
Okay, so you saw from that way how the NVMe, the amount of capacity you want from the pool can be allocated out, and if you delete the composed node, it can be returned. So check that out, latest feature in our live RSD demo. Okay, and what RSD is really driving is the software-defined data center, and in various 3 major categories or applications. So the first one is just cloud services, right? So for example, how would RSD and Wiwynn Cluster Manager, which is our in-house software GUI, overlaid on top of Intel rack scale design, how does that work? So let's say for cloud service, you need X amount of computing power, Y amount of I/O throughput, and Z amount of storage capacity. So using our Wiwynn Cluster Manager GUI, you can allocate specifically the amount of power and throughput and storage you need. Okay, and then that'll create the composed node. And what benefit does this offer is scaling up dynamically and optimizing for your workload. So you get an amount of resources that you need, just the right amount. So you're not encountering underutilization. And as well as big data analytics has its own various needs, maybe like larger storage capacity and such. So you can tune your composed node that way. And similarly for AI, you would need a lot more computing power. So you can allocate a lot more resources that way to your composed node. And if you feel like you don't need it, just pop it back into the pool. And thereby rounds up our disaggregated and composable rack solution. So yeah, coming down the line is just actually in about 25, 30 minutes, Sunlight Chang, our Senior VP and Chief Technology Officer at Wiwynn, will give an executive talk about the 4 fundamental demands I mentioned earlier, really about performance, cooling, power, and data. So please check out that talk, because these 4 talks will highlight the 4 workshops we have, and Wiwynn is very excited to bring with you from our engineers tomorrow. So the first one would be the performance, and specifically tomorrow at 10 a.m., so we will have a high performance scalability. So this is the PCIe Gen 4 performance. Jackie Hung, our director at Wiwynn, will be able to present this talk to you, and you have any Q&As, you can face-to-face have a deeper conversation with them. And next, similarly with the power, we present the 2-stage 48-volt solution. And John Lin, our director power at Wiwynn, will be able to present those details to you as well. So they're all very excited. And thirdly, we have the cooling solution and also the 2-phase rack level. And Lentis Pai, our associate director of the mechanical and thermal, Wiwynn will be able to present that for you. And finally, to round out, in terms of data, Ted Peng, our senior director of software, will show you how to apply big data analytics to manufacturing applications that we have the capability because we're doing that right at the front level. So these test results for DRAM module, he'll be able to present these results to you. Yeah, so so I hope you attend these workshops and get a better view of where Wiwynn is going in the future. And to really round it out, so this is a very exciting time that you've seen how AI is driving. And just recently, going to some social events, I've noticed something interesting. Just even talking to kind of people not in the tech industry, people have really seen like for example, where do you work, what do you do typically, and it's in the data industry. Or I say data or kind of big data AI. They say, oh, that's really cool. So not only is this age of AI coming to terms right now, I feel like enterprise-grade electronics or these things are actually becoming more mainstream, and people are accepting it and think it's really cool. So it's a really privilege to be in this industry, and I'm very excited to meet all of you and to be able to speak to all of you. And Wiwynn gives a big welcome. Hope you come to our booth and our talks and thank you very much.